Hi, I am Tomohiro Amemiya from the University of Tokyo, the Virtual Reality Educational Research Center. So today, I would like to share my research on the resizing of peripersonal space for the seated for different step frequency of vibration at the soles. So the main goal of this talk will be the how to find the how we can create a sensation of walking and how we can quantify the effect. So first, let me show you what I'm doing. And so the now I'm working on creating a sensation of walking without the body actual motion for seated users. So usually a sensation of walking in a VR was mainly created by a locomotion device for people who are actually performing a walking motion, walking action. But instead, I suggest a way to create sensation walking for seated by combining the multisensory stimulus, multisensory information. In this case, I used the motorized the chair to move the user up and down with presenting vibration at the sole of the feet, and whose cycle was identical to that during the actual walking. So the participant will feel the kind of the impact on the ground but with in a locking on up and down motion. So usually the realism of a walking experience is examined through the subject to scales or questionnaires. Instead, I have focused on the size change of the peripersonal space, the PPS. So as shown here, the previous studies have measured the size of PPS by the neural activity or the behavior index. So the one example is the reaction time. So the rightmost figure shows the audio tactile interaction task to capture the critical distance from the participant's body where the approaching sounds affects the reaction time. So the results show that the tactile reaction time decreases when the walking on the treadmill. Here I measured the tactile reaction time without the actually walking, but the feeling a sensation of walking. So at first, what kind of the vibration was clearly induced the sensation of walking? So we tested three kinds of the vibration, the walking sound, sinusoidal, and the asynchronous walking sound vibration pattern. And we found out that the walking sound vibration is clearly, strongly induced a sensation of walking. It means the highest scores among the three conditions. And also we found that when we applied it at the sole of the feet, it clearly felt clearly induced the sensation of walking, but not at the forearms. So we similarly we tested this effect using to measure the reaction time, and we found that a walking sound vibration facilitates an audio-tactile interaction even when the running sound, approaching sound was 1.2 meters from the participant's body, but not with the other types of vibration at the sole of the feet. So these results show that the inducing a sensation of walking without any body action would be sufficient to trigger the extension of the effect in PPS representation rather than the motor or proprioceptive signals. So the next question is the what if the same waveform pattern is applied to the soul at the different step frequencies of vibration? So I use the three types of the interstimulus onset of step, 80%, 100%, or 125% compared with the kind of the previous experiment. So Unfortunately, we found a clear result in this case, but still, 100% of the sleep frequency has a clear effect of the expansion of the PPS. But the other 80% or 135% of the sleep frequency was not clearly shown that they are clearly expand the PPS, the boundaries. And this will be because of the difference in the working dynamics between among these conditions. Because I used the same frequency, same waveform pattern, but when we change the speed of walking, the waveform itself also changes. So probably the participant might be very sensitive to the change of the kind of the waveform according to depending on the kind of walking speed. So they feel some kind of the mismatch between the walking speed and same waveform pattern. So that will affect the effect of the reduction of the PBS size. And this is the short summary of my talk. Thank you.